Hello students. So in today class we will study about a topic complex number. What is a complex number? Okay. So to understand the concept of complex number, I will take an example. If I ask x square plus 1 is equal to 0 and x square minus 1 equal to 0. I take these two examples, and if I ask both of all of you that what is the solution of these equations, what are the solution of these equations? So first of all, I will take this example: x square minus 1 is equal to 0. If I factorize it, so I will get x minus 1, and x plus 1 is equal to 0. So solution will be 1 and minus 1. So number of solution, if I ask, will be what? 2. If I ask number of solution of this equation, so many of the students will answer that it has no solution. Why? Because it is x square plus 1. When we square x, then it will give positive number, and addition with 1 will never give you 0. So no solution. No solution. But exactly it's not correct answer. Correct answer will be what? It has no real solution. It has no real solution. What it means? It means it can have any other solution called complex solution or imaginary solution. How we solve this equation? So see here, x square plus 1 is equal to 0. If I transfer x minus 1 there and put root of minus 1 plus minus. So we defined negative number, or we can say minus 1, root of minus 1 is as a iota, imaginary quantity. We define here root of minus 1 as imaginary quantity iota. It's imaginary quantity. It's imaginary quantity. Okay, what it is? Imaginary. It is imaginary. So if I put here iota, I will get x is equal to iota or minus iota. So for this equation, I have two. For this equation, I have two solution, iota or minus iota. But these are not real solution. So if I ask number of real solution of this equation, answer will be 0 or no solution. But if I ask number of solution of this equation, it can be iota minus iota. So there are two solution possible, but they are not real, they are imaginary. Okay. Now I also take an example of another quadratic equation. See here, x square plus 2x plus 2 equal to 0. If I want to solve or I want to find its solution, its roots, I use formula minus b plus minus under root b square minus 4ac upon 2a. So root will be x will be minus b plus minus under root b square minus 4ac upon 2a. So I will get minus 2 plus minus under root 4 minus 8 minus 4 upon 2. I can write minus 2 plus minus 2 root minus 1 upon 2. Okay. So what I get? I get here x is equal to minus 1 plus minus iota. So I get two roots. X is equal to minus 1 plus iota or minus 1 minus iota. So these roots are complex roots. So I define here complex number. Complex number is not a number actually. It's a representation. What? It's a representation of a point in Argand plane. Simply. Okay. So any number, any number, any number represented in form of this x plus iota y is called complex number. Okay. Getting my point? This is root of this equation. So now I will give definition of complex number. complex number. Any number represented in form of x plus iota y called complex number and denoted by z. Okay, so I write z is equal to x plus iota y. I say z is equal to x plus iota y is a complex number. Sometimes we misunderstand the concept. We say it's real part of z and its imaginary part of z. I ask, what are the real part of z? The real part of z will be x, and what will be the imaginary part of z? That will be y. Not iota y. Iota y will be wrong answer. Okay. So iota y is imaginary number. It's an imaginary number, not imaginary part. Imaginary number. Iota y is an imaginary number, not imaginary part. If I ask imaginary part, then it will be coefficient of iota. It will be coefficient of iota. Getting my point? Okay, write down. But we cannot define complex number like that. Z is equal to x plus iota y. So can't say that complex number is addition of real number and imaginary number. This definition will be wrong. This is not correct. This is wrong. Complex number is addition of this part is wrong. It's only a representation. Complex number is a representation of a point in Argand plane. What I mean, if I say this, I can denote is like a point x comma y. Here in 2D, x-axis denote the real axis, and y-axis denote the imaginary axis. Okay. So only one point where real and imaginary part meet is only origin. Okay, write down. Now I discuss about iota. I have done iota as root minus 1. Root minus 1 is iota. Okay. So if I square, I get iota square minus 1. Iota cube will be iota square into iota, that is minus of iota. Iota 4 will be what? Iota square to the power square minus 1 square. So iota 4 will be what? 1. So iota 4 is 1. What it means? It means after cycle of 4, it repeats its values. So I say iota 4, iota 8, iota 12 and so on all gives value 1 because all these are factor of 4. Okay. If I divide a number by 4 gives remainder. What it can remain? If iota power n divided by 4 divided by 4, remainder will be what? 0, 1, 2, 3. These 4 remainder can I get? 0, 1, 2, 3. So if I get 0 remainder, it will give iota power 0, that is 1. If 1, then iota square, that is minus 1, iota cube, that is minus 1. So I will get only these 4 values. I will get only these 4 values. So I have to remember these 4 values: iota square, iota cube, iota 4. This is root minus 1, minus 1. Okay, this is root minus 1, minus 1, and minus iota and 1. Okay, I will take some example on this. If I ask what is the value of iota to the power 234, so I divide power by 4. 234 divided by 4. Instead dividing whole number, I divide only last two digits because divisibility rule of 4 says that if last two digits divided by 4, then whole number will be divided by 4. So if I divide 34 by 4, I get remainder as a 2. So it will be iota square, that is minus 2. If I ask 1 upon iota, then it will give what? Multiplied with iota into iota, iota upon iota square, that is iota upon minus 1, that is minus 1. So remember, 1 upon iota gives minus of iota. Okay, so I generalize here, iota power 4n will give 1, 4n plus 1 give iota, 4n, iota power 4n plus 2 give iota square, that is minus 1. 4n plus 3 gives iota cube, that is minus 1. Sometimes we can write like this also. Iota power 4n minus 1, iota power 4n minus 2, iota power 4n minus 3. So how I write this? 1 upon iota, that is minus iota. 1 upon iota square, that is minus 1. 1 upon iota cube, that is iota. So, however, I get all these values, repeated values. Okay. So, now I take a question asked in exam. Solve solve this. Before solving this, I give you a new concept also. Iota plus iota square plus iota cube plus iota 4. What it will give? It is iota, it is minus 1, it is minus iota, it is plus 1. So cancel out 1 by 1, minus iota, that is 0. So concept is sum of 4 consecutive powers of iota gives 0. Okay, 4 consecutive powers of iota gives 0. So I apply this concept here. Listen, from 1 to 12, I will give you three groups of 4 4 4 4 4 4. I will get three groups of 4 4 4. So that will be 0. Remainder what? 13. So if I put 13 here, iota bar 13 plus iota bar 14, that is what? Divided by 4. Iota plus iota square, I will get iota minus 1. That's it, simple. We can solve it directly. If I put 1, then 2, then 3, then 4, up to 12, I will get pairs of 4 4. Okay, so that will give you 0. Remainder will be 13. So 13 put here and here, so I will get 14. So that's, after solving this, I get iota minus 1. Okay, there is another method also. How can I solve this? Take iota power n as common, because here here n, sorry, n, iota power n is common, so I will get what? 1 plus iota, summation n equal to 1 to 13. Okay, now summation depend on n, so it is a constant, so take it out. Now 1 plus iota n. From 1 to 12 it will give 0, remaining will be 13. So 13, if I divide by 4, I get iota. So 1 plus iota into iota. When I multiply, I get iota minus 1. Same answer. Okay. So I can solve like this or this method. Getting my point? Now z is equal to x plus iota y. Okay, it's a complex number. Here, the real part of z is x, imaginary part of z is what? Y. First point, purely real, purely imaginary. And third will be what? Imaginary. There are three concepts: purely real, purely imaginary, and imaginary. If I say that a complex number which is purely real means there will be imaginary part will be 0. So I say here x can be any real value and y is equal to 0. Always purely imaginary. What it means? Real part will be 0. So here x will be 0 and y belongs to any real number. But imaginary part also be real. Note it down. Okay, note it down. For in case of imaginary, what I say? Y cannot be 0. Means y can be any real number except 0. Except 0. Y cannot be 0 for imaginary number. Okay, and x can take any real number. X can take any real number. It can be 0 also. It can be 0 also. If it is 0, then it is purely imaginary. Okay. But what about 0? What about 0? Because 0 is written as 0 plus iota into 0. 0 plus iota into 0. 0 is written as here. 0 is can written as 0. 0 can written as 0 plus iota 0. So real part also 0, imaginary part also 0. So we say 0 is only a complex number which is both purely real as well as purely imaginary. Okay. Thank you.